Okay, so if you're given a limit like this where t approaches 0, first thing you want to do is substitute it in. And we've already figured this out, that if you put a 0 here and a 0 there, that's going to give us a limit of 0 over 0, which makes no sense at all. So that's a problem. So you can't just substitute the value in because it's obviously there's some kind of discontinuity. So what you're going to want to do then is you're going to want to try to get this, you're going to free this t from the root sign here. You want to try and factor out a t so that you can write something like this where there's a t outside that could cancel with it. That's where you're trying to get. But you can't just simply do that, can you? So this is what we're going to do. Okay?
How would I rationalize?
Exactly. You want to rationalize the top. So how do you rationalize the top? That's when you multiply the top and the bottom by the conjugate. Very good.
Sorry, just a second. I'm going to write something.
Which the conjugate is the same terms except the opposite sign. And of course, you want it, whatever you do to the top, whatever you multiply by the top, you have to multiply by the bottom as well. Okay? Because you don't want to actually change this ratio. You want to change this function, right? So you can multiply the same thing times the top and the bottom. So this is what it's going to give you. All right, so if we multiply this, notice that it's the same terms, but opposite sign. So when we did that before, just think, don't write this down, but watch this. If I multiplied these two together, what do I get? That's the factored form of a what? Difference of squares, exactly. That's what I get. So I don't have to multiply and write down all the terms. I can just notice that, hey, I'm going to end up with this term squared minus this term squared. That's what I'm going to end up with. So that's just where you go. What's the square of a square root? That's, yeah. So the square, when you square this, that square root is gone. So it's like this, just 2 plus t. And now t is out of our root sign. And then, of course, minus the square of root 2. So root 2 squared is 2. Okay? Now, this is very important underneath here. Very, very important. You don't, when you do this, when you rationalize, don't distribute this t into this. Keep it separate. Just write it like I'm going to write it here. Because you want to get it out anyways. Exactly. So, oh, okay, whoops, I made my plus sign like a t there. Whoops. Anyways, so yeah, so keep it like this. Keep it in factored form in the denominator. That is something you want to do most times. And then look at what we have on top here. You see how we have now a 2 minus 2? So that's going to be all gone. And now I'm left with this. Limit as t approaches 0 of just t on top and a t as a factor on the bottom. Yeah, no, take your time. Okay. But what that does, then you can, these t's divide out. It is, yes, it's 1 over, because remember, when you, like, and you're saying kill these t's, right? That's what the term you use. Well, they don't just disappear, because a lot of students do that, and they think, well, look at those t's are gone, and even us teachers say they're gone, but look at, does that look right? Like, what is this, nothing over this? No, no. It actually, what they turn into is a 1 over 1.
But you need to take the 1 off on the bottom.
And the 1 off on, yeah, the 1 on the bottom is like it's not even there. So yes, it turns out to be this right here. Okay? Now, you're kind of, maybe you might be saying to yourself, well, what good does that do us? Because now I have a root in the denominator, and, oh, but look, this is not root 2 minus root 2 anymore. This is root 2 plus root 2. So if you just insert 0 into t here, you don't have 0 anymore. You see that?
So that's 1 over 2.
So this is 1 over the square root of 2 plus 0 plus the square root of 2, which you're right. 1 over 2 root 2.
So if I see a shortcut, I just skip 2 steps and just go around every